Okay, I'll just take a review of the previous class until other joins, so that we can start once the remaining will join. Okay, I'm just taking a review of the same. So last class we have discussed about the syntax and semantics, right? How to describe the syntax. What is this? What do you mean by syntax? Syntax is a set of rules that governs whether the sentence is well formed or not. You said, right? So if you can, if you want to make some notes, you can probably make some notes. I'll just dictate until the others join. You can write down. All of you can please write down some notes here. The syntax of a programming language is the form of its kind of expressions, statements, and program units. Its semantic is the meaning of those expressions, statements, and program units. For example, syntax of a Java while statement is while Boolean expression. Then you will have the statements under this while statement, right? Even C while statement is also the same value, right? Lexemes are the small units. We said it is undividable atomic units of the language. It includes identifiers, literals, operators, and special symbols, words. A program is a string of lexemes rather than characters. A token of a language is a category of its lexemes. For example, I'll take one example and show you with an expression. For example, you have an expression index equal to 2 into pound plus 70. Okay, index equal to 2 into count plus 17. So this statement, if you see, you have left hand side index and the right hand side you have 2 into count plus 17. I'll clear the frame and I'll write it again because it's not properly written. I'm practicing it now since these are my beginning classes to teach you using this kind of approach. So just cooperate with me. Index equal to 2 into pound plus 70. Okay. I have an expression like this. Okay. In this, what are the lexemes? Okay. I'll just list out here. You can see lexemes. Index is a lexeme. Equal to is also a lexeme. 2 is a lexeme. Into is a lexeme. Like that, count plus and 17, right? Now, what do you mean by token? Token is a group of or a category of lexemes, sorry, right? So category of lexemes we call them as tokens. Index belongs to which category? Identifier, right? It belongs to identifier. So the token of index is identifier. Equal is belonging to equal sign token, right? Equal sign token. 2 belongs to int literal. Int literal. Okay. Into Into is a multiplication operator, right? Multiplication operator. Fine. Uh, Count here. Sorry. Right again. Lexemes. So under lexemes, the remaining lexemes in that given statement are count, and you have plus, and you have 17, right? And then I have, yeah, semicolon. If every sentence is terminated with a semicolon, right? So I have a semicolon. Now, what are the categories of these lexemes are said to be the tokens. So now count is also an identifier because it's a variable kind, right? And plus the plus operator, right? 17 is an integer literal, right? And then you have this semicolon, belongs to semicolon. Fine. So for a given expression, index equal to 2 into count plus 17. Okay, and if I take this semicolon here, because every statement is terminated with a semicolon, right? Fine. So in this statement, what are the lexemes? How do you identify the lexemes? The lower level units are the atomic units of the language instruction. Like index 2, count plus 17. You can see these are the atomic units. They cannot be further divided. They are the lowest level of unit. What do you mean by token? Token is a category of lexemes, rather, right? So index belongs to identifier, I'm saying, because it's going to be varied. It's being used to identify, certain value or certain data type, rather, right? So they comes under identifier. Equal sign. Then you have int literal. 2 is an integer literal, and into is multiplication operator, right? And the remaining are count. Count belongs to identifier, plus belongs to plus operator, 17 belongs to int literal, and semicolon belongs to semicolon, right? And we have discussed in the last class that the language recognizes, right? Language can be defined in two distinct ways, by recognition and generation. To formally define languages L using the recognition method, we would need to construct a mechanism R called a recognition device that is capable of reading string of characters from the alphabet sigma. I hope you are fine putting the points, right? In effect, R would either accept or reject the given string. When does it accept? When the sentence is well formed. It is written as per the syntax, right? The syntax analysis part of a compiler is a recognizer. So what recognizer basically does, it analyzes the syntax and checks whether the syntax of a particular statement is correct or not. This comes along with the compiler. In effect, syntax analyzer determines whether the given programs are syntactically correct or not. Syntax analyzers also known as parsers, right? Syntax analyzers also known as parsers. Okay, so fine. Language generators. What is language generator? It is a device that can be used to generate sentences of a language. It helps to determine whether the syntax of a particular statement is correct by comparing it with the structure of the generator. And generator is already given all the structures of your programming constructs, so it will compare the syntax of a particular statement and checks that whether it is being matched with the structure given by the language designer to it of that programming construct. Okay, so then we have discussed in the last class formal methods of describing syntax. There are two widely used standard methods for describing the syntax. One is Baker's norm form, invented by John Baker's, and another one is Chomsky norm form, right? Developed by Noam Chomsky. Context-free grammars. In the mid-1950s, Chomsky, a noted linguist, 4 classes of generative devices are grammars. 2 of these named context-free and regular. The tokens of a programming language can be described by regular grammar. Whole programming language, with minor exceptions, can be described by context-free grammar. The origins of Baker's norm form. BNF is natural notation for describing syntax. It is a meta language the other way around, you can say. When do you say anything as a meta? When it is describing about the other of the same kind, right? A meta language means language defines a language is said to be the meta language, right? A meta language is a language that is used to describe another language, right? So BNF here, I can say, is a meta language for programming languages, right? BNF uses abstraction for syntax. The structures. A simple Java assignment statement may be given as, you can write a simple assignment statement like this, right? Assign statement defines to be variable equal to expression. Okay. The symbol of LHS is the abstraction being defined. The text to RHS, the text on RHS is the definition of the LHS. Consists of mixture of tokens, lexemes, and references. Altogether, the definition is called rule or production. Provided variable expression must be defined before assign becomes useful. So this variable and this expression must be defined before this assign becomes useful. One example sentence whose syntactic structure is described by the rule is total equal to sub 1 plus sub 2. The abstraction is in BNF or grammar are often called as non-terminal symbols. Okay, the left-hand side you find non-terminals. The right-hand side you find both terminals, non-terminals. Okay, lexemes and references. Okay, so a grammar or BNF is a collection of rules, I can say. All of you are noting down, right? The non-terminal symbols can have 2 or more distinct definitions. representing two or more possible syntactic forms in the language. The multiple definitions can be written as a single rule separated by symbol. Vertical bar. The meaning of the symbol is logical or. For example, if you have to write the if statement syntax. Okay, so let me write here the grammar for if statement. Okay, if followed by the logical expression then statement. What do you mean by it? If statement is defined to be if followed by the logical expression. If this condition is true, then you're going to execute this particular statement. Or you can even define if statement with else combination. How do you define if statement? Defines to be if logical expression then statement else another statement, right? Else another statement. You want to now combine both of them. You can use the or symbol here, logical or symbol. I'll show you in the next slide. Now I'm defining by combining both of these definitions of the if statement, right? If statement is the non-terminal here is defined to be if logical expression then statement okay. Or I should say R here. This vertical bar is to be R here. I'm now giving another definition for the same. If logic expression then statement else another statement. So now while defining the grammar, we'll combine, right? If there are multiple definitions for the same statement, you can combine it with the help of this R symbol, right? This R symbol. This R symbol, right? Right now, describing list. Variable length list in mathematics are often written using an ellipse kind of thing. When you have list of elements, how do you represent in max? You will represent it with the help of elements enclosed in an ellipse, right? Inside that, we can give the elements as 1, 2, 3. Okay. So now, if I have to define the grammar for the identifier list, how do I define? Clear it. I write identifier is defined to be identifier are okay. So if you observe this, the identifier list is either a single token, like this identifier, or an identifier is followed by comma followed by another identifier list. Okay, you can see here this identifier list is defined in another definition with identifier followed by identifier list. What do you mean by this? On the right hand side, you find again same as this left hand side. Right? It means this definition is recurrently applied. This is said to be recursion. Okay. If the left hand side appears on the right hand side, I say that rule is a recursion. Got a point? So you can write down. A rule is recursion if its LHS appears in its RHS. Okay? All of you please note it down. A rule is recursion of its a rule is a recursion if its LHS appears in its RHS. Yes, all of you are noting down, right? Write down grammar and derivations. Charity. Grammar and derivations. Grammar and derivations. Under this, please write down. A grammar is a generative device for defining languages. Full stop. The sentence of language. The sentence of language are generated through a sequence of applications of the rules. I'll repeat it. The sentence of language are generated through a sequence of applications of the rules, beginning with a special non-terminal symbol of the grammar called the start symbol. A sentence generation is called a derivation.
So beginning with a special?
Yes?
So beginning with a special?
Beginning with a special non-terminal of the grammar called the start symbol. Full stop. A sentence generation is called a derivation. In a grammar, for a complete programming language, the start symbol represents a complete program and is usually named as program. Now let us define the grammar for a program here. Okay. Now let us write the grammar for program. Program is defined to be, it starts with begin, right? Begin is also one like C, right? You use braces in few programming languages. In few programming languages, you write begin. Okay. Then you will have the statement list. Then you have end. But then what is the statement list is, right? You need to define the statement list. Statement list consists of set of statements, right? We are defining these non-terminals in angle brackets. The statement list is defined to be statement or you can say statement semicolon statement list. Now you can see there is a recursion here in the statement, right? Because you can see the LHS part is available in RHS. Yes or no? This is your LHS part statement list is available here as well again. Because here we have defined the statement list as it could be a single statement or it could be multiple statements. How do you define multiple statements? Statement followed by statement list. It means this statement list again can be a further single statement or it could be again a statement followed by a statement list. Okay. So this kind of rule we call it as recursion. Fine. Okay, now let me define this statement. How do I define statement? Statement is defined to be a variable equal to expression where this variable is defined to be an identifier, right? It could be A, B, or C. Okay. Did you copy the previous slide? Okay. Shall I move on to the next slide? Okay, I think I can move on. Now I am defining the expressions, right? Expression is defined to be variable plus another variable or variable minus variable or just a variable. So the expression here is defined with three definitions. One definition is just a variable, I said, is just a variable where variable is already defined as A or B or C, means some kind of identifier. Here variable is, I said, variable can be variable plus variable. If you observe here, okay, you got this variable on both left and right side, okay, and here also, right? Fine. Now let us derive the program in the language. Taking an example here based on this grammar. Okay. So this is clear to all of you. instead of this example, I'll take another small example for you to explain how we are going to derive the grammar for a given statement. Okay, let us take another grammar. Let us take another grammar. Assignment statement I'm taking. An assignment statement is defined as ID equal to expression. Now this ID is a non-terminal, then it must have to be defined, of course, before assign becomes meaningful rather, right? So ID is defined to be A, I said B, I said C. Now this expression is defined to be ID plus expression. And this expression can be further defined with another definition as, let us say, ID into expression. I can give another definition as expression enclosed in parenthesis, or simply it could be an ID. Now we will try to understand this grammar. We'll try to understand this grammar. So I have defined a grammar here for assignment statement. So here you can see the assignment statement is defined to be ID equal to expression. Okay, where ID is either A or B or C, is it, right? Now this expression, right? This expression is defined as ID plus expression. You can see here, you find this expression on the right hand side. See, the LHS part, if available in the RHS part, we say this kind of rule is a recursion. Okay. So here I found this, LHS on the right operand. I found it as a right operand of this operation plus. Okay. And similarly, when it is defined with another definition, ID into expression, you can find again this expression here. This expression is further defined by enclosing it in a parenthesis, and expression is further defined as just an ID. It means expression could be just an ID, or the expression could be enclosed in parenthesis, or it could be into, or it could be less, right? So here I can take any of these definitions for defining the expression. Okay, I'll take one example here. Let me take one example. I want to derive this grammar with the help of a statement, with the help of one statement. I'll show it in the next slide. All of you have noted down this grammar. Shall I move on to the next slide? I'm going.
Excuse me, sir.
Yes.
So what does it mean if an expression is enclosed in a brackets? I mean, enclosed in parentheses?
Yes, that I'll discuss probably while I'll be probably defining or deriving it. The order of precedence actually will take from the bottom to top here, right, Radhan? So expressions will be given more precedence than into, then less like that. Okay. Anyway, we'll see. If you have multiple, operators, and there are certain which are enclosed in parentheses, will have to be evaluated first. That precedence rule also being automatically taken care here in this particular one, rather, right? We'll see with an example. Move on to the next slide. You have noted down the grammar, so you have a grammar at your hand on your paper. Just let me derive one statement using this grammar in the next slide. Okay. Let us take one statement. Okay. A equal to B into, in parenthesis I have A plus C. Okay, so here I want to derive this statement based on the grammar which I have defined before. So how do I derive it? Assign, this is assignment statement, right? So assign, when I'm deriving, I'll use this double line here, right? If I'm in the grammar to define the LHS part, I am using arrow. In arrow, you find only a single line. If there is a single line in arrow, it is a grammar, rather, right? And this is derivation. When I am deriving a statement using the grammar, I will be using double line here, okay? Fine. So assignment statement is derived to be, I'm saying derived, right? Instead of defined. Derive with ID equal to expression. Okay, and I'm writing in the next statement. At this ID, I'm opening this ID. ID can be A or B or C, right? I want this expression or the statement to be derived. So in place of ID, see this grammar, this particular definition, I have taken it from the grammar only. You can see assignment equal to ID equal to expression. This definition I have taken, right? So that I have written here. Now in place of ID, I can take either A, B or C, right? But in order to get this particular statement, I am taking in place of ID as A, right? A. So A equal to the expression, right? A equal to the expression, right? Now, because I may not find space here, instead of writing just behind this, I am taking here, this arrow here. Now, left hand side A I have got, but now I am expanding this expression. But while I am expanding this expression, for expression I have multiple definitions. Which definition I should take here in order to get that particular statement to be derived? Okay, I will go with into. I'll go with into here, right? If I go with plus, what happens? I'll probably tell you next. ID into, I'm taking this definition. Expression, I am expanding it with the definition ID into expression. Yes or no? You can see here, this definition I'm taking for the expression, right? ID into expression. Now in the next statement, what is it I'm saying? A equal to, in place of ID, I'm taking B, okay? The ID can be A or B or C. Into, now in place of this expression, which definition I should take in order to get the addition operation enclosed in parenthesis? I should take this definition, right? Expression enclosed in parenthesis first. So expression is defined to be with ID plus expression or ID into expression or expression enclosed in parentheses or ID. So I'm taking this particular definition, at this junction. So expression I'm saying as, expression enclosed in parenthesis. Okay. Now in the next statement, I say A equal to B into, now within this parenthesis I have expression. So again I have to expand this expression because it is a non-terminal, right? So for this expression I am taking the definition of plus because I need to get A plus C there rather, right? So I can go with this definition now for expression in enclosed in parentheses. I'm taking the definition of ID plus expression. ID plus expression. Is it clear to all of you? Now I move on to the next slide if you have noted down. So now A equal to, so far what we have got, A equal to B plus, B into within brackets, when I have expanded expression into ID plus expression, in place of ID, I can take A because my statement is A equal to B into A plus C. So I got A in place of ID. Now ID plus expression I have, right? You can see here, you have A equal to B into ID plus expression. So in place of this ID, I have taken A in order to get this. But in place of expression, I need to get identifier only. It means I need to go with this definition for expression now, right? I should go with this definition. Expression can be defined as even ID also, right? So I can say expression is defined as ID. Got it? Now in the next step, when I'm deriving the same, I say A equal to B into A plus, in place of ID, okay, I have another definition. What is the definition for ID here? ID is A or B or C. So in order to get my statement to be derived based on this grammar, I should take in place of this ID as C, right? Yes or no? So you can see here, I have been able to derive the A equal to B into within parenthesis A plus C using this particular grammar, right? Using this particular grammar. So while defining the grammar should have all possible options. Only then you can able to derive the statements. If the grammar is confined to only few operations, like here it is confined to only plus and into. It means if I have a statement where I have minus operation, I cannot derive it. So the grammar, which when probably designed by the language designer, he will ensure that all possible options will be taken into consideration, and at the same time he will even ensure that that will generate a unique derivation. You can see here I got one derivation. Okay, I got one derivation. Can you be able to derive it in other way and get another derivation for this particular grammar? I don't think you can derive because it is an ambiguous grammar. For ambiguous grammar, yes, we can be able to derive in more than one way, right? Fine. So this derivation which I have done is said to be left derivation. Okay, leftmost derivation. Why should I say it is a leftmost derivation? Because when you see, I have expanded. When I was expanding the non-terminals, okay, when I was expanding the non-terminals, I was expanding it from the left side onwards, right? First, I got A, you can see, yes or no? First I got A, then I got B, then I got A here, then I got C. It means I was getting the identifiers been derived using that grammar while I was deriving from the left hand side. Okay, so this kind of grammar is said to be leftmost derivation based grammars, right? So I hope this is clear to all of you. Now what I have discussed here the grammar. I have defined the grammar for assignment statement, and then I took one statement here, okay, and that statement is derived using this particular grammar, and I'm saying this grammar is based on leftmost because when I was deriving, I could able to see the identifiers I get for my statements been derived from the left hand side onwards, right? And this grammar is said to be a recursive grammar as well. Why? You can see here expression, the left hand side of this particular grammar is available in the right hand side. When you find the LHS part in the RHS, you say the rule is a recursion, and this particular recursion is said to be the right recursion, right? So for right recursive grammars, you use leftmost derivation. For left recursion, you use rightmost derivation. I hope it is clear to all of you. If you have any doubts, you can probably raise. Otherwise, we'll stop here. Okay, we'll then see in the next class how to generate the parse trees from the derivation. Okay, from the derivation.
Excuse me, sir.
Yes.
Sir, can you say what is start symbol once
Yes,
again?
start like for example, if I have taken program grammar defined, program is the start symbol, right? Okay. For assignment assignment statement, what is assign is the start symbol, right?
Okay, thank you, sir.
I'm stop presenting from my end.